Hi, welcome to clickmeproject.com. The title of our project is Attacks and Defense in the Data Planes of Network. Security issues in the computer network has focused on the attacks on end-to-end system and the control planes. An entire new class of emerging network attacks aim at the data planes of network. Data planes forwarding in the network routers has traditionally been implemented with custom logic hardware, but recent routers design increasingly use software programmable network processing for packet forwarding. These general-purpose processing devices exhibit software vulnerable and are susceptible to attacks. We demonstrate to our knowledge the first practice attacks that exploit a vulnerable in packet processing software. To launch a demonstration to our knowledge, the first practice attack that exploit a vulnerable in packet processing software to launch a devastating denial of service attack from within the network infrastructure. This attack uses only a single packet attacks to consume the full link bandwidth of our routing outgoing links. We also present a hardware-based defense mechanism that can be detected suitable when malicious packets try to catch the operation of the network processor. Using a hardware monitoring, our NetFPGA-based protocol system checks every instruction executed by the network processor and can detect deviation from the correct processing within 4-clock system. A recover system can restore the network process to a safe state within 6 cycles. This high-speed detection and recovery system can ensure that network processor can be protected effectively and efficiently from this new class of attacks. Now let's see the architecture diagram. This is the source node and this is the destination node. The node denote that the systems. Okay, now we are going to send a file. It's framed on each file data. A header is set because the reason for attaching the header is while receiving the data it may be of unorder. So to arrange and order the data, the header is added. The header will be added as H1, H2, H3, H4, etc. So while the data is being transmitted in the destination node, any packet may be dropped and rebooted again and recentered. So to arrange the packet that received the destination node, the header is added. While receiving, the header will be added in the order H1, H2, H3 and so on. Now let's see the demo of our project. As we are doing a client server application, we have to run both application. Now I am going to run the client. This is the client home page. Then I have to run the server. This is the server page. Before transmitting a file, we have to start the server. So click this button. If the server has started, the color will be changed. Now from the client, I'm going to send the file. We have to give the destination IP address. The destination IP address is 192.168.0.17. Then the file that we have to transfer. How to check the IP addresses? Click the button. Open network and chat center. Then local area connection detail. This is the IP address of the destination system. So send the file. The destination is going to be receive the file. So the transaction is going to prepare it. The file has transferred. Now the first segment has been received. Then the second segment has blocked. As well as in the server side, you can see the same transaction is being done. Now the third file is being received. The second file is blocked. It's been restarted and sent successfully. Then the fourth segment is receiving. As well as in the client side, you can see the same transaction is being done. The fourth segment is blocked, so the fifth segment is ending. After the fifth segment, the fourth segment has resendered and the task has completed. Now in the client side, we can view the service time required to send each and every segment of the file that the client has selected and transferred. This is the service time that is needed to send the file. Then the process delay. This process delay represents the time delay that required to transfer the file segments. So the segment 1 required the high amount of milliseconds to transfer the file, and the segment 2 has been the lowest part of our file transmission. Then as the monitoring process, we have to click the button. We have to get the surrounding network IP. Then we have to accept the particular network. Then the service checking has to be done. In the service checking, we have to click the service checking button. In the service checking button, we can monitor the process. This monitoring process input is get from the segment delay. In the segment delay process, we will be get the input and we have to initialize it. So the monitoring process is take place. In the monitoring process, its level will be increasing, decreasing. It won't be stable because depending upon our network, the transaction waves vary. So the monitoring process is done like this. We can click the network sampling rate is 926 and the network bit rate is 538. It will be changed depending upon the file and depending upon the network. Then close the button. We can do the analyzing process. This analyzing process will analyze the network speed, range of the destination and the source. This is the analyzing process strategy. This represents the system capacity that required to transmit the file and the network allocation, how the network is allocated to process it. Then the destination net speed and the source network, the initial router, the network findings, then the topology that is used is also being monitored. The purpose of our project has been over. Thank you for watching.